Hi all, it's Laura and I'm back to talk to you again from some more of our Python class we've been taking. Again, I'm working with the book and we're going to look at constructors, objects, using the self argument, and what that constructor object thing is inside of our class and how it affects stuff. So I'm using the pythontutor.com/visualize. That seems to help a little bit to see what's going on. Let's go ahead and define a class here. So I've got class. And I used vehicle last time, so let's go with that one because we kind of understand that one. And we're going to use object because that goes along with our book, and we will in like chapter 9 cover why that is there. Don't want to start adding too much in because if I add more stuff in, sometimes that confuses you worse. So let's give this a chance. So in the past we've had def, honk, so our definition for our function. We had our honk. We need to have self be the first time because that's an instance of itself. We don't pass anything into it. It's just referring to itself. It's a Python object that, or a Python argument that lets it control what's going on with itself. And we're going to print the /a so that it would actually make that noise, and however many times we tell it to honk. So what we'll do is we'll pass in the number into times, and it will be multiplied times the /a, which will make it beep. That's all good. So let's go ahead and give it an attribute. We've got doors. How many doors are we going to have? We'll set that to a neutral state with none. We have windows, which is also going to be set to a neutral state with none. And again, if we were to take and add in equals empty quotes, it's not neutral. It's now a string. It's a subtle difference, but we're going to use it that way so that we don't have it set to a string or set to a float already. Now I'm going to go back and I'm going to click just before my definition of honk. And I'm going to say that I need to initialize this class. The minute it's created for a new object, I want to initialize some of the settings. I want some of it to immediately have information. So we're going to do def underscore underscore init, so init, and parentheses, and this gets a self also. And let's say that we want to initialize what model it is and how many wheels it has, because that does make a difference on whichever vehicle you're driving, whether it's a Toyota, a Mack truck, a Harley Davidson. What are we driving? So to refer to itself, we're going to say model. The self's concept of what model is going to be equal to what is passed in for model. And self.wheels is going to be equal to the wheels. So I'm saying this class, when it becomes an object, is going to initialize the model, so this self, and self is referring to itself, I suppose. It's awful to use the same word in the definition, but there we go. So self.model is going to be equal to what's handed in for model. Self.wheels is going to be equal to what is handed in for wheels. And each time we initialize a new object, it's going to replace that information for that object. And without the self, it won't do that. It doesn't understand that we're just saying just for this time around, not for every time around. So there's our constructor, and our constructor is the underscore underscore init underscore underscore. It's defined just like a function, but Python sees underscore underscore init init as something special. It understands that's the first thing run it immediately when we call it. So let's go ahead and call it. I'm going to make a car that is a instance of vehicle, the class vehicle, and I'm going to hand in Toyota. And I'm going to say it has 4 wheels and a running board. Oh, that's an old song. So we're going to say print car. And when we do this, the print car should just say I'm an object. It shouldn't give you any information, just that it's an object. Car.honk. We're going to tell it to honk 3 times. Car.doors. Let's say that this is a 4-door. Car.windows. So the dot notation, that using a period to link the two together, is saying I'm using the parts from the class that were constructed, but they're going to go with this object called car. And let's say it has 6 windows. So it's setting these values for the car object, but basing it off of the blueprint that was written in vehicle. And then we'll print this vehicle has, and because we have to convert it to a string, because these will come through as ints, because we've got 4, 6, they're not floats, they're ints. So this car has, oh, let's see, car dot doors. We'll just go with that much for now. Plus space doors. And end quote, parenthesis. I'm not going to do a lot right there because I want to see how that works. So let's go ahead and visualize this. Hopefully I did all my typos correctly. If you're going to typo the same thing both times. So right now, over on our right-hand side, we don't see anything defined. Our program has not run, and class vehicle object is going to be the first thing to run. So we'll go ahead and step forward, and we see that a global variable has been, or a global class has been defined. We could click and hide the attributes or show the attributes. It has an init function, it has a doors attribute, a honk function, and a windows attribute. When we initialize it, it went down, it ran cars. If you can see the light gray on line 12, there's a light gray arrow. It says that was the last thing that was run. So when it ran, it jumped up to our initialize function because that's the first thing to run. And so it said, okay, model is Toyota. We have a vehicle with an empty instance, which is going to go to cars, but it's not quite there yet because the initialization is going through first. The init method is running first. And it's going to say self.model. We're passing that in. Okay, model. There's a vehicle instance with Toyota in it. There's a vehicle instance with 4 wheels in it. And that's been given to self at the moment. You can see how the line comes down from self. And then it's assigned a car, because what car does is it says run the class, class does its thing, and then shoves all of what it returns back into the car variable, which becomes an object. So car now holds Toyota and wheels. It should next try to print it. It says, hey, this is a vehicle object. All right, good. I'm glad about that. Car.honk, and we get it to honk 3 times. That gets put into the class. It goes back and references that, and now obviously we don't have to rewrite everything from the class. The program's taking care of that for us, so we don't have a lot of code bloat by redoing the wheel over and over and over again. Oh, that was a bad pun. So car.doors, we've now added doors into our attribute for the car instance, and we get windows, and we print it out. Yay! So let's go back and edit our code. We do have the class, which is sitting there as the framework, and we have the duplicate of that, which is now the car, which has information plugged in. Let's make another object. Let's see if we can do a couple of these. How about we do a dually? I hope that's how you spell dually. Equals vehicle. It is a Chevy, and it has 6 wheels. And dually dot honk. How many times do we want it to honk? 4. Let's see, dually dot doors. Well, it's not an extended cab. We're just going to go, it's the straight cab. It's big enough with the dually wheels. Dually dot windows. And we'll say that it's got, about 6 windows. No? 1 on each side. Well, we'll do 4. All right, we'll do 4 windows. And while we're right here, let's make a bike. It's a vehicle, so we'll do a vehicle. So it's an instance of the vehicle class. It is a Harley. What other kind of bike would you want, right? I know some people say, I want a Honda Goldwing, whatever. So we've got a Harley. It's got 2 wheels. Our bike now can honk. It doesn't have to. You don't have to put that in there. Bike.doors. Well, there are no doors on a bike. So we got 0. Bike.window. We don't have windows, so we're not even going to pull that. We're not going to even populate that section. We don't have to. So our bike should exist. Let's see how this goes. We'll go stepping forward. We have, I'm going to go quickly through this one. We got an instance with our Toyota, and the car becomes a Toyota with 4 wheels. It has 4 doors and 6 windows. We then end up with a Chevy truck here. So our dually ends up becoming a Chevy with 6 wheels. Oh, data type error. So none type object is not callable. Let's go back and look at what our problem was. Dually doors. Did I write this wrong? Dually dot doors equals, oh, I put parentheses around it. Why weren't you guys yelling at me? You probably were. If we'd been in class, you'd have been yelling, going, Laura, what are you thinking? It's all right. There we go. We are really programming here. It's kind of like when you really are cooking, you burn things because you're not paying attention. All right, so as we go down through, this should work this time because we didn't do the call incorrectly. So I've got a dually. Is it coming up? There's our dually. The dually is getting everything it's supposed to. Let's see if our bike happens. And our bike happens. So on the right-hand side, you can see these arrows going down. The vehicle class is populated with all of the framework to make our vehicles. The car got all of its information for the attributes. The dually got its information for attributes, and the bike got its. So everything is populating based off of our class, and we don't have to rewrite all of that information. This would be great for doing players in a game. You know, Fred, the wizard, and all wizards have a certain type of class that go with them. Or you've got George, the warrior, and warriors all have a certain setup in the class. So this way you can actually make this little rubber stamp, essentially, and you can go along and stamp everything, and then fill in the stamped areas to make it its own unique individual object. But the framework is there. It's kind of like a template for something. And if you notice, we've had a great time doing the initialized part. That init runs first. It gets everything set up for us so we know it's a Toyota or it's a Chevy, it's a Harley. So hopefully this helped some. Don't forget to give me an email if you need any help, GurneyL@husson.edu, and I will talk to you guys later.